All right, example number 3 says that a 120 ohm, a 60 ohm, and a 40 ohm resistor are connected in series with a 110 volt power source. We're going to be asked to draw a schematic diagram, find the equivalent resistance of the circuit, find the current from the power source, then find the current through each resistor, and then find the voltage drop across each resistor. So the first thing is to draw our schematic diagram. I want you guys to know that there is no flat out one solution for the schematic diagram. I'm going to draw kind of the easiest way to find this overall, and then we're going to look at a couple other ones. All right. So we have to start by putting in our power source. So there's our voltage source. I'm going to put a resistor here. I'm going to put a resistor here, and then one there, and I'm going to connect them all. Right? Now that's the way I've done it. I'm going to go ahead and label those 110 volts, 120 ohms, 60 ohms, and then this one is 40 ohms. You guys do not have to draw it like I have drawn it. There are numerous correct answers. Another way you could draw it if you really wanted to would be like this. Right? 120, 60, and then 40. If you guys wanted to draw it a different way, you could do this. Right? 120, 60, 40. Again, it does not matter how you guys draw it, as long as you draw it some way that makes sense to you. I will say this, as far as it doesn't matter how you draw it is concerned. If you draw it so that the current does not have to go through every resistor, then it's wrong. But in each of these schematic diagrams, any single electron would pass through every single resistor. An electron leaving here would go through this one, and then this one, and then that one. An electron leaving here would go through this resistor, then it would have to proceed through that one, and then it would have to proceed through that one. So as long as it's drawn like that, it's correct. All right, these are kind of our 3 acceptable ones. Something you could note if you wanted to move that battery and put it down here, or down here, up here, here, whatever, you could do that, but I kind of prefer to have them on the left side. So anyways, there's our schematic diagram. Part B says, what is the equivalent resistance of the circuit? Okay, well, we know that RT equals R1 plus R2 plus R3 for a series circuit. All right, so that means that what we're going to do is go ahead and plug everything in there. RT is equal to 120 ohms plus 60 ohms plus 40 ohms, right? 60 plus 40 is 100, so that means our total resistance is going to be 220 ohms. So if we want to know the current from the power source, let me go ahead and label that B, this is C. If we want to know the current from the power source, we're going to say V equals I times R, only I'm going to put some subscripts in here so that I know specifically which ones I'm talking about. This V is going to be, I'm going to go ahead and just say A to B to indicate that it is the power source. I realize you can't really read that because it's pretty small there, but it does say A to B. I is going to be what we're looking for, and then R is RT. And here's the reason I've done it like this, because our current from the power source, if we have other circuits, then it's going to change depending on if it's a parallel circuit or not. But in this one, all right, for the current through the battery, it is always going to be equal to the current times the total resistance of the rest of the circuit. So voltage from A to B is 110 volts, and it equals I, which is what we're looking for, times 220 ohms. Divide both sides by 220. Cancels out there, and we get that I is equal to 0.5 amps. Right? So the next ones we're going to look at are D. D says, what's the current through each resistor? I equals 0.5 amps. All right. Do we have to break this down into anything more complicated than that? No. We know that if you have 0.5 amps of current coming out here, that is a specific number of electrons per second moving through. It's not a half an electron per second, okay? But that means that that same number, they're not going to stop somewhere in here. So they have to proceed through this one, through that one, and through that one. All right. So I'm going to go ahead and put 0.5 amps, 0.5 amps, and 0.5 amps at each one of those on my drawing. And I'm going to also put it up here, 0.5 amps, right? And just for grins, I'm going to say RT equals 220 ohms right there, just so that I can see everything on my diagram. All right, and you guys shouldn't have that as a divided by. It's just that I wanted to put it right there next to it for some reason rather than underneath it. So anyhow, we have a half amp going through each resistor. Okay, well, the last question says, what is the voltage drop across each resistor? Well, if we want to know the voltage drop across the 120 ohm resistor, we're going to say V equals I times R. Well, if voltage equals current times resistance, then we're going to say current is 0.5 amps times 120 ohms. So voltage across resistor 1 is going to be equal to I, 0.5 amps times 120 ohms, which is equal to 60 volts. That is the voltage dropped across there. Remember what we talked about the other day with voltage. Voltage is similar to water pressure, but it's kind of like how many electrons you have crammed in this space here. Once we get across the resistor, we're going to have fewer electrons crammed on the outside of this area of wire here, fewer here, and then fewer here. Now, the amount going through each part at any particular amount of time or given period in time is going to be the same, okay? But it's just that we have more electrons crowded around here, which gives more electromotive force, right? So V2, we want to find the voltage at 2 is equal to 60 ohms. Actually, let's just go ahead and say 0.5 amps times 60 ohms, which is going to give us 30 volts. And then V3, same thing, 0.5 amps times 40 ohms, and that's going to give us 20 volts. All right, you can't see that, but there it is. So if we want to put that back in the circuit diagram next to everything else, we can go ahead and say 60 volts, 30 volts, and then this one was 20 volts. If you'll notice, the higher the resistance, if they have the same current going through, the higher the resistance, the higher the voltage drop. Higher the resistance, 60 ohms, the higher the voltage drop. This is half as much resistance as that one, which means it's going to dissipate half as much voltage as that one is. This one is 1/3 as much resistance as that one, so it will dissipate 1/3 as much voltage as that one will. All right.